Okay, so for this problem, you're given the equation y equals x squared plus 2x minus 4 over the denominator x minus 1. Because the degree on top is larger than the degree on the bottom, you will never, ever, ever have a horizontal asymptote. And in this case, you will always have a slant asymptote or a hole in the graph. Now, how do you determine which one it is? So let's take a step away from this problem. If I could factor this, I'm making this up. If I could factor this and it factored into this, okay, what would be our next step? Okay, when you can cancel out and there's nothing left in the denominator. And by the way, when I say nothing left, I mean only a 1 occurs. As a reminder, when you can cancel things out, what does it really replace with? So when you can cancel this out and you have nothing in the denominator, we say there's a hole in the graph. So our first step in attacking this problem is to ask yourself, can you factor the numerator? So do you know two numbers that multiply to equal -4 and add to give you +2? Okay, if you can't factor it, there's no way to cancel at the bottom, and it means you will absolutely have a slant asymptote. If you can't cancel out the denominators, when you factor the numerator, then you absolutely have a slant asymptote. Well, we couldn't even factor the numerator, so we will have a slant. Now, how do you do this? The numerator goes inside, the denominator goes outside. And it's a 4-step cycle. X times what is x squared? Answer is x. That's step 1. Step 2 is to multiply. Step 3 here is to switch the signs of your second level. And step 4 is to cancel out here. Okay, x times what is 3x? Is a +3. Multiply, cancel out, and combine. When you determine the slant asymptote, we don't care about the remainder. We only care about this expression up here. Y equals x plus 3. It's important to put y equals. It's an equation. That's our slant asymptote. We've almost got the hardest part of this problem done. Actually, we really have done the hardest part. Now, your vertical asymptote, like all other problems, comes from your denominator. So in this case, it is x equals 1 by taking this, setting equal to 0, and solving. Okay, let's come down below. Let's start by graphing the easier of the two. We're going to do the vertical asymptote. Go to x equals 1 and dot in with your highlighter the vertical asymptote. Then go to y equals x plus 3. So y equals x plus 3. How do I graph that? Well, I start at +3, 1, 2, 3, and I go up 1 over 1, up 1 over 1. And I do the exact same pattern going the opposite direction. Okay, so some students get to this point, they're like, I get that, but how do I know how to graph it? Your calculator is going to do the work for you, but you have to know how to make it easier for yourself. So go to where you find the vertical asymptote. What two numbers do I have to the right? 2 and 3. What two numbers do I have to the left? Those are going to be my suggestions for what to plug in. Okay, let's do this together. Go second plus 7, 1, 2. Go to y equals. And I'm going to plug in exactly what I see. So it's parentheses, this is the original, x squared, plus 2x, subtract 4. That's in parentheses, divided by parentheses, x, subtract 1. Okay, we're going to hit graph. Remember, your asymptotes won't show up on your graph because they're invisible. Your calculator does the work for us. Be thankful that you don't have to do this all by hand. How do you come up with these corresponding y values? Second trace value, I'm typing in 2. 2 goes with 4. Second trace value, you can start graphing these on your own right now. 5.5. Second trace value, 0 goes with 4. And -1 belongs to 2.5. So graph those 4 order points. Remember to include arrows showing that it continues to move downward in this case and up to the right. Notice for this problem, we will identify the zeros, but we'll identify the domain, but we don't have to do the range or the end behavior. So let's do the easier of the two. Domain. Is there any limit how far this will continue to move to the left? Bless you. Is there any limit how far this will move to the left? So I go negative infinity. Now it's going to go from the left and it's going to keep moving to the right until it hits what vertical, excuse me, I used the wrong terminology, until it approaches what vertical wall? 1. Okay, jumps over, starts at 1, and there's no limit how far it moves to the right. For this particular problem, notice it says that we're going to round the zeros to the nearest tenth. Now, I can see the zeros are in this range. Does everybody see this? So let's get rid of some of this extra space here. So let's go Windows, and let's try from like -5 to +5, just to have a smaller view of where it crosses. I want to see exactly where these cross. So I change the windows to do -5 to +5. Let's start with this first one. Okay, second trace 0. I'm going to take that cursor, I'm going to move it. It says left bound. That means find the x-intercept, and in this case, left bound means below. So go somewhere below, press enter. Directions are now right bound. Somewhere above, press enter, and now back to the x-axis. So -3.2, -3.2. So whether you write x equals -3.2 or you write it as an ordered pair is up to you. Now let's choose the next one. Second trace 0. I'm going to hold down that cursor and just keep holding it down as I watch the x values move closer and closer to 1. Oh, there it is. Okay. And I can see it drops off pretty quickly. So there's left of it, which is in this case is below. Right is somewhere above, and going as close as I can to being back on that spot. Rounded to the nearest tenth is 1.2.